Colleagues, please forgive me for the moments when I seemed a bit unfocused. And so I realize that I have taken up quite a bit of your time. So I would like to speed things up and, if possible, be a little more concise. In general, I would like to present to your attention a brief summary of my work on the use of innovative approaches in studying activities related to similar records. And I will start my report with something non-standard, something that usually comes at the end when conclusions and results are announced. To make it more interesting and clear, I want to present this right at the very beginning. I would kindly like to ask you, if you don't mind, to please show slide number 2 next in the sequence. Yes, please. Where is slide 2? Now we are waiting for slide 2. Is it visible? Yes. Well, we can't see it. 4. Is the slide visible? The slide is visible. Slide 5? 6. And the last 7th slide. These were the main points that I have presented to you. So in fact, I have thoroughly and carefully presented the work in detail, making sure to cover all the important aspects and information that I have accomplished. Over the years that I have been working on innovative approaches to researching thyroid threats. Please tell me, is the presentation visible? No. No, it's not visible. Oh my God, I'm sorry. It always starts with me. At least we can hear you. That's already a win.
Why the attention?
Why the attention to the research? Why is there particular attention drawn to the study of the thyroid gland? The thing is, the thyroid gland is an extremely fascinating organ. It is known that the control and regulation of the entire body is ensured by a triumvirate, the nervous, immune, and endocrine systems. But in this triumvirate, the key role belongs specifically to the thyroid gland. Why the thyroid gland? The thing is, the thyroid gland is actually responsible for important protein synthesis processes, for effective communication with other endocrine organs, and for maintaining overall connectivity within the body. In fact, its proper function is essential for the body's overall balance and well-being. With the organs of the entire body, that is, today there is a well-established understanding that the thyroid gland is absolutely essential and critically necessary for all vital processes in the human body. Despite the fact that the thyroid, which is an essential gland, remains critically important for overall health, today we are observing a global trend of increase, the latest critical threshold. Tell me, please, can you see the slide now? Yes, now we can. Oh, then I apologize. Is it possible to go back? Or maybe shall we do it this way? What I originally intended to present as an intrigue at the beginning, we will actually give at the end. Is that option possible? Of course. Oh, wonderful. So currently there is a steady and consistent trend of increasing thyroid pathology being observed worldwide, regardless of whether it is in developed countries or in developing nations, countries with a lower level of economic development. This situation is associated with a number of factors, but in any case, it occurs against the background of iodine deficiency. Today, it is believed that due to the biogeochemical characteristics of soils, these biogeochemical features may involve both iodine deficiency and soil acidity. In such cases, the soil does not release the iodine it contains. Thus, due to the biogeochemical characteristics of soils, 40% of the world's population, almost 3 billion people, are at risk of developing pathological conditions to varying degrees associated with disrupted iodine levels, Please. Slide 8. Thus, the need for a deeper investigation of the peculiarities of thyroid gland function is, without a doubt, extremely relevant. At the same time, it is important to emphasize that the current stage of development in biology and medicine is characterized by a significant expansion of research methods, and the material itself is becoming extremely important. According to the general systems theory, the biological organism is a self-regulating supersystem that integratively and cohesively combines systems of lower levels. We have proposed to consider their overall organization at 3 distinct levels of structural functional hierarchy. Then, from the standpoint of cybernetic concepts of a biological object, we can study the specific features of the functioning of each level. In this case, the thyroid gland, as a cybernetic self-regulating system, simultaneously functions at 3 levels of hierarchy, which we have designated as the organelle cellular, tissue organ, and systemic systematic levels. To study the thyroid gland at the organelle cellular level, it is necessary to examine follicular thyrocytes, that is, the cells that produce thyroid hormones. Understood? This is a defined scientific direction. It requires the development of a new multidisciplinary concept for studying the thyroid gland. So the aim of my presentation is shown on this slide, on slide 10. The main research methods, such as those commonly used in this field, are presented here on the next slide. I will focus on some methods in more detail. First of all, yes, please show the methods. Please show the methods, the main methods. Oh, thank you. So, firstly, this is classical electron microscopy, and secondly, a set of specially adapted mathematical methods. The mathematical basis of the applied methods was the combination of several informative techniques. The object of the study is the electron microscopic image of follicular thyrocytes, which is traditionally presented in a linguistic, that is, qualitative form, the descriptive and interpretive parts of which largely depend on the experience, qualifications, and priorities of the researcher. At the same time, this can lead to subjectivity in interpreting the obtained data. To make the picture more objective, we relied on the principles of fuzzy logic, which allows qualitative and binary data to be transformed into quantitative indicators. This is one mathematical method. Next, the principles of phase interval were applied, that is, working in Euclidean space. This approach involves comparing the state of the studied objects with corresponding benchmarks. The next method, mathematical statistics, involved averaging the numerical parameters obtained when evaluating the components of follicular thyrocytes. Furthermore, and this is very important, the author's own research methods were thoughtfully developed and implemented in practice. The method of semi-quantitative analysis of electron micrographs, which allows the transformation of linguistic descriptions of electron microscopic images into numerical equivalents. And this method forms the basis for another method of determining the profiles of hormone-producing cell capabilities. The data obtained by these methods were used for 2-dimensional Pearson correlation analysis, followed by the application of the Chedak scale, which made it possible to trace the relationships between significant components of the studied clusters, establish their mutual influences, and interpret the obtained results from the standpoint of cytophysiology. The developed multidisciplinary approach to studying the activity of follicular pterocytes at the organelle cellular level of hierarchical organization consists in the sequential application of the aforementioned mathematical methods. And the research algorithm involves 7 steps. Please, slide 11. Yes, we can already see slide 11. Step 1, this is formalization. What is the point of this step? What is the point of formalization? The activity of a hormonopoietic cell occurs simultaneously in 3 directions. Namely, in 4 directions. Classical science, excuse me, let me explain why I said 3. We usually talk about 3. From the perspective of classical science, but I am adding a 4th direction. The first direction is the synthesis of the hormonal product. The second direction is its secretion. And the third direction is transportation. But these processes are impossible without energy supply. So we can say there are 4 directions. According to the fundamentals of cytophysiology, from the entire set of ultrastructural components of the follicular thyrocyte, we distinguish clusters, which are groups of organelles that carry out specific directions of activity. Each element of the cluster is designated by a specific symbol. In this way, the clusters are formed. These represent the synthetic, secretory, transport, and energetic capabilities of the follicular thyrocyte. So, for example, slides 12 and 13 show electron micrographs of follicular thyrocytes that were studied. Among all the organelle complexes, certain organelles stood out. These are responsible for each of these functions. Step 2, quantification. After visualizing all the elements of the studied cluster according to the principle of the phase interval, a qualitative comparative quantification is performed to determine their proximity to or distance from 2 reference points, normal and pathological states. These reference points are the electronograms of follicular pterocytes, intact ones, in our case from rats, and those from rats with the uncorrected studied pathology. Next, we move on to steps 3 and 4, that is ranking and evaluation. This is done to transform qualitative, that is linguistic indicators, into quantitative, that is numerical ones. In each cluster, following the principles of fuzzy logic, the degree of manifestation of each element's properties is ranked. After this, according to the scoring system we developed, their numerical evaluation is carried out. The absence of a feature is 0 points, a weak manifestation is 1 point, a moderate manifestation is 2 points, a significant manifestation is 3 points, and a strong or maximum manifestation is 4 points. The results obtained are averaged using mathematical statistics. The next 5th step is the creation of a database. Within each cluster, Pearson's correlation analysis is used to search for relationships between the elements of the cluster, determining their strength and direction, which are assessed according to Chaddock's correlation scale. The most significant are considered to be very strong and strong correlations, but for a more comprehensive and representative study, it is not just advisable but necessary to also take into account noticeable and moderate correlations. The results obtained are entered into a matrix, and as an example, a matrix is presented for your attention. The very strong ones here are red, red-violet. Blue indicates strong correlations. Noticeable ones are dark green, and some grayish ones represent moderate correlations. You see, there are certain obtained numbers everywhere, and each has a certain value, whether positive or negative. Steps 6 and 7 are the creation of correlation portraits, step 6, and their interpretation, step 7. What is a correlation portrait? A correlation portrait is a tabular representation or a graphical depiction of the observed correlation links between the components of a cluster. The observed correlations between the components of the cluster are carefully taken into account, including both their strength and direction. The interpretation of the mutual influences in correlation portraits is based on data from cytophysiology and fundamental concepts of biological systems, as well as approaches to studying them in both normal and pathological conditions, according to which any biosystem is characterized by the properties of its elements, the degree to which these properties are expressed, and the direction and strength of the connections between its elements. And now comes the most interesting and the most beautiful part. To illustrate what has been said, yes, please show slide 15. Slide 15 presents the cluster of synthetic capability of follicular therapsids. We can see that the elements of the cluster are the cytoplasm, the granules of cytoplasmic suspension, lytic, free ribosomes, polysomes, and the Golgi apparatus. And on slide 16, please show slide 16, there are graphic correlation portraits of the same synthetic capability of follicular therapsids traced in male albino rats during administration of moderate and high doses of organic energy, iodine under model conditions of hypothyroidism. Yes, please, slide 17. Slide 17 shows the cluster of secretory capability of follicular thyrocytes. Again, we see the components of the cluster: apical microvilli, lysosomes, secretory vesicles, all described in great detail. And on slide 18, we see the geographic correlation portraits. When taking a moderate dose of organic inorganic iodine under the same hypothyroid conditions. Yes, please, slide 19. Slide 19 presents the transportation capability cluster. Please, basement membrane. There is the most complete characteristic of the percapillary space. Very complete characterization of endothelial cells. And slide 20 for your review provides an overview of graphic correlation portraits that were recorded during the admission period. I won't list which doses. Small, moderate, and large doses. That's not so important. I want to show, please, slide 21. It presents a slide on energy capability. When we describe the quantity, shape, and size of mitochondria, we characterize mitochondrial cristae and the mitochondrial matrix. On the slide. On the next slide, slide 22, graphical correlation portraits are presented. Yes, you can really see just how deep it is. It's truly impressive. How should I put it? Immersed, well, as they say, the intimate mechanisms of hormonopoiesis. Intimate means very subtle mechanisms of hormonopoiesis. The approach presented has revealed, in fact, these very subtle mechanisms of hormonopoiesis, which we will later discuss, so to speak, in the conclusions. Now, I would like to ask for what should have been shown at the beginning. It was unavailable. Oh, the main results of the study. Thus, we have proposed and tested a comprehensive package of mathematical approaches for studying the follicular thyrocyte as the basis of the organelle cellular level of structural organization of the thyroid gland, with the consistent application of the principles of clustering and Pearson correlation analysis, as well as the principles of phase interval and fuzzy logic in mathematical statistics. This contributes to the objectification of the obtained results. Yes, please continue. Authors' methods for semi-quantitative analysis of electronograms and determination of the profiles of the functional capacities of hormone-producing cells have been tested. These methods involve quantifying cellular components according to their specialization, followed by transforming qualitative and binary indicators into quantitative ones through digital assessment. This enables the study of in-depth methods. The mechanism of urgent MPS under conditions of varying functional activity of the thyroid gland. Next slide, please. The use of Pearson correlation analysis to create correlation portraits of the various capabilities of follicular thyrocytes makes it possible to trace the relationships between the elements of the profiles under different conditions of the thyroid gland, which allows for a deeper study of its interdependence, to characterize each area of activity, and to better connect their features under the influence of factors of different nature. Next slide, please. We have conducted a comparative study of the effects of organic and inorganic iodine on the characteristics of the thyroid hormone PS, which makes it possible to deepen our understanding of the thyroid gland's function under normal and pathological conditions, expand the range of research methods, and enable a selective approach to choosing appropriate iodine compounds for correcting the body's condition. Next slide, please. Thus, it has been proposed to use markers of the morphofunctional state for an in-depth study of the synthetic activity of the follicular thyrocyte system. At the initial stages, these markers include changes in the number of free ribosomes and polysomes, as well as the condition of elements of the granular cytoplasmic reticulum, which we have designated as markers of primary changes. At the final stages, the markers are changes in the number of fixed ribosomes and polysomes, and the condition of the Golgi apparatus elements, which are designated as markers of final changes. This deepens our understanding of the morphofunctional changes in follicular thyrocytes at various stages of thyroid hormone production, and broadens our perspective on the activity of hormone-producing cells. Yes, just the next slide. Hormone-producing cells. It is very interesting to establish the concept of the irritating dose of iodine. That is, the dose that changes the morphological state of the elements in the profile of the studied capability, and the correlations between them, while at the same time there is a possibility, that is, a probable breakdown of previous adaptive mechanisms and disruption of hormone production. Determining the irritating dose allows for the selection of the chemical nature and dose of the iodine-containing preparation to correct hypo and hypothyroidism according to the functional state of the follicular thyrocyte. Why do I mention the possibility of choosing the chemical nature of the iodine-containing preparation? Because nowadays, iodine deficiency is mainly corrected with inorganic iodine compounds, although there is already a substantial and comprehensive amount of available scientific research and proposals regarding the use of organic iodine compounds. In our utility model patent, we have clearly and explicitly delineated the situations in which it is more appropriate to use organic iodine and those in which it is more appropriate to use inorganic iodine. Let me explain. Briefly, the more appropriate use of inorganic iodine is in cases of reduced functional activity of the thyroid gland and its functional impairment. Why? Because organic iodine has a very strong stimulating property. All right, please go ahead now. Yes, slides 23 and 24. The multidisciplinary approach to enhancing the activity of the thyroid gland presented to your attention is a harmonious combination. It is a harmonious combination of the requirements for such empirical accumulation of experimental data and their fundamental application. Next, the testing of follicular thyrocytes under various conditions and pathologies. This will contribute in the future to improving the treatment of thyroid pathologies and optimizing the prevention of disorders caused by iodine deficiency conditions. Dear colleagues, thank you all very, very much for your kind attention, for your patience, and for allowing me to speak, even despite the circumstances. The initial difficulties. Thank you very much.